In this example, we're going to determine values for a and b for this linear system such that the solution of this system is going to be 5, negative 3. So since this is the solution, I know that 5 will be my x-coordinate or my x value, and negative 3 will be my y-coordinate or my y value. So over here in the system, every time I see an x, I'm going to plug in 5, and every time I see a y, I'm going to plug in negative 3. So let's go ahead and see what that looks like. So a times x, which is 5, minus b times y, which is negative 3, equals negative 2. So this would be 5a plus 3b equals negative 2. Okay? So over here, let's look at the second equation. So b times x. So b times 5 minus a times negative 3 equals negative 14. So this will be 5b plus 3a equals negative 14. Let's go ahead and stack these two equations on top, taking care to go ahead and stack vertical terms that are like. So this 3a will actually be underneath this 5a, and this 5b, and then negative 14. Okay, so it looks like I'm going to be using elimination to solve this system. So my 5 and my 3, which are coefficients for a, they're not really factors of one another, but then 3 and 5 for the b's, they aren't either. So I know I'm going to bring this 3 up here and this 5 down here. But since my a's are both positive, one of these things needs to be negative. So let's go ahead and make that 5 a negative. Now it's a matter of distributing these values through. So 15a plus 9b equals negative 6. And when I distribute this negative 5 through, negative 15a minus 25b equals a positive 70. So you'll notice my a's will cancel out. And again, that was by design. For my b's, I have 9 minus 25, which would be negative 16b equals, and negative 6 plus 70 will be 64. So it looks like a quick division by negative 16 will make my b value negative 4. So now once I know what my b value is, let's go ahead and plug that back into one of these equations. And I'm not going to plug it into the original equations way up here, because we already did a lot of work with our x and y to get down to this point. So let's just plug it back into one of these. Let's say this first one here. So 5a plus 3b, and b is negative 4, equals negative 2. So 5a minus 12 equals negative 2. So when I add 12 to both sides, 5a equals 10. And it looks like my value for a is going to be 2. Okay? So what this means now, if in the original linear system I knew the solution was 5, negative 3, and I needed to find values of a and b that made this true, I now have done that. I plugged in what I knew, which was my ordered pair solution, 5 and negative 3 for x and y respectively, and I found that the value of a was 2 and the value of b was negative 4.